All right. Good afternoon, everyone. So welcome back to another hopefully exciting time of discussing computer programming, object-oriented programming. All right, so this is March 29th, 2023. And what we'll do is we're going to talk about exceptions today. Now, the title of this lecture set is Exceptions in Text I/O. We covered text input-output in CSE 101, so I will not go through that here today in detail, but there is a reason why this is done in the same chapter. So we wanted to put the text discussion into the 101 course, but there are some things related to exceptions that's covered as part of text I/O. Remember that stuff that we did last semester where it was like, for now, just know that this is what you have to do. Later, we will talk about the why. Now we're getting to the why, right? And so the same thing is whenever we told you, public static void main, string array, args, and we said, just type that in and know that you have to put that in there. Later, we'll talk about the why. Later we got into the why. And the same thing is true here. With the text stuff, we talked about using a try-catch block. We also talked about the throws file not found exception as part of your method declaration. And we just said, just do it for now. We'll explain the why later. Now we're getting to the why. Okay, but first, Blaise Pascal. I really like this guy. So again, those that have my database class, you guys know that we did this quote today there. But Blaise Pascal, who's considered the father of modern computing, there is a programming language named after him. You've probably heard his name in your mathematics classes as well. He was a great scientist, mathematician. But today he brings us a non-technical quote about all men's miseries, all sadness derived from not being able to sit in a quiet room alone. And, as I shared with the database class that I was listening to a podcast about there's a new health condition that they're concerned about that people are getting called text neck, which is where people are having neck and spine problems from staring down like this at their phone too much during the course of the day. So make sure you keep yourself healthy by looking around at the beauty that's all around you. Take a walk outside, put your phone down for a few moments, all right? And just be able to enjoy this earth that we get to live on, look up into the sky and see the stars. Okay? All right, enough philosophizing. Let's move on. All right. So, what's a runtime error? We have talked about in the previous class in 101, right? There were 3 types of errors. Runtime error was one of them. You guys remember the others, I hope, right? Remember what the other type of errors were? There was runtime error. Does anyone remember the other types of errors that we had?
Syntax and logic.
Yeah, so you had the syntax error or the compiler error. We also had the logical error. So the compiler error is, again, it's where there's something written wrong in the code itself where the compiler cannot take what you've written and make it into executable code. The logical error is after the program is done, it completes execution, it compiles, it completes execution, but the results are not the correct results, right? But that middle error that we talked about, runtime error, right? Well, sometimes we want to be able to generate a runtime error, right? Most of the time in 101, what we did was when we encountered a runtime error is we said we have to figure out how to fix this. We have to figure out how to get rid of it. But there are some times where we don't want the program to continue to run if there's some problem, right? So for example, if there's an input that's wrong, right? So a user enters an invalid value. We need to let them know, hey, this is not okay, right? We shouldn't continue running this method or this program if the user puts an invalid value in, or if what else? Or if just anything, if there's some type of, like, if they try to access an array index that doesn't exist. All right, so we'll talk about here how we can use runtime errors to our advantage, and we'll even talk about how we can create our own runtime errors. All right, so here's 3 examples. We will talk about these. We will show these. And the example is the quotient, right? I don't remember the Turkish for quotient, but it's when one number is divided by another number. And, you know, if you divide 5 by 3, or, 21 divided by 7, that should give you a normal result, right? But what if the user enters 0 as a number to be divided by? So what is 1 divided by 0? Right? Well, that doesn't really make sense, does it? Right? So we can have a couple of different ways to handle the situation if an invalid value is entered. We can have an if statement to check if it's invalid. We can have a method about it being invalid, but we can also generate an exception that tells the method, that tells the calling program, I was not able to complete. And then that calling program can have the capability, the chance to handle that error itself or terminate the program. Right? It depends on what level of problem we encounter. Okay. So we can also look at an example here talking about how to read input until we get a correct input. All right, so an input mismatch. If the input type is incorrect, we can keep asking for correct input until the user finally decides to give us correct input. Now, you guys should know this type of diagram, the UML class diagram. We talked about this already. This symbol means is a. So remember, everything in Java inherits from the object class, right? So a throwable is a type of object, right? An exception is a throwable type of object. An error is a different thing. Well, we could talk about that. That's a different type of thing. Mostly what we'll be talking about in this class will be the exception class. Okay. There are things like IO exception and class not found exception, which can come up. But most of what we'll be talking about, most of what we've encountered so far, things that ended your programs in 101, were these runtime exceptions. This was mostly what you encountered in 101 whenever you were trying to do something and got a problem. Right, so, excuse me. So arithmetic exception, right? A type of arithmetic exception would be a divide by 0. Okay. An index out of bounds exception would be if we tried to access an array using a negative index value or using an index value that was too large. Okay. Okay. Now there are 2 types of exceptions. There's checked and there's unchecked exceptions. Unchecked means anything that the program that could be encountered in the program, but it would be kind of too much for the compiler to try to see if that's a chance or if there could be a possibility there. Let's see. So for an example, an index out of bounds exception. All right. Because this is something that could happen, but hopefully your program has done enough to make sure that how can I say this? Right, generally, these would be considered errors that should be corrected in the program, right? So it does not require, Java does not require you to catch the unchecked exception or to deal with it in any way. Okay, it could just occur, and so this is what happened for a lot of you, a lot of me, and a lot of me. This is what happened for me as well when first learning Java. Is that things like index out of bounds exception, divide by zero, arithmetic exception, these things occurred when we were running our programs because the compiler does not check to see if that potential exception could occur. So this is the list of types of unchecked exceptions. Okay. Now, checked exceptions, I don't think I have a slide on that, but checked exceptions are like the file not found exception, right? So a checked exception, what it's saying is you're trying to use the file class. And because I know that the file class could throw an exception if the file is not found, then what I'm going to do is I'm going to require that you show that you're going to handle it in some way. Now, you could handle it by using a try-catch block, which would mean I want to deal with it, I want to handle it, right? Or you could handle it by throwing it up to the calling program, and that was the whole where in the method we wrote, you know, throws file not found exception or throws exception, right? That when we said that, we are telling the compiler, I know this exception that you are checking for, I know that it can happen, I'm handling it this way. All right. So there's a couple of different ways that we can handle exceptions, right? We can catch it, or we can throw it. We can say we know that it's going to throw this exception up to the calling program. Now, there's a difference between throws and throw. In fact, let me get the pen going. All right, okay, that little letter S, right, is a little bit of a difference. Okay, now, throws exception is telling the compiler as part of this method definition, I know that this method could throw this exception. This exception could happen as part of this method. Without the S, throw is actually the action of generating and causing this exception to occur. Okay. So you could say throws IO exception. This method, the stuff inside of this method could result in an IO exception or another exception. Okay. This is telling the compiler, I know that the method below could result in this particular type of exception. Okay. Now, the exception, whatever exception is that it is that you are generating, notice the new keyword, right? Right, the new keyword. That's because exceptions in Java are a class type. Therefore, when they are encountered, they are an object. And just like every other object, they have a constructor, they have methods, they have a toString method, they inherit from the object class, right? And so when you create an exception, not that. When you create an exception, you're creating an object. Just like any other object, we can create a reference variable for it, right, if we want to, and we can assign it to that. We can throw through the reference variable, or we can throw by generating a new exception here. Okay. So when this line is encountered, if this line is executed, immediately this exception, whatever it is generated, and if it is not caught, then it will be continued up the method calling chain until it either does get caught or it ends the program. Question? Question? Okay, so if somebody has a question, I can't hear you. Okay. So let's take a look at an example of throwing an exception here. Okay, now you can set the radius value. We talked about this using the set radius. This actually, this reminds me of a question that I've gotten from a couple of students regarding the assignment. Okay, about the variable naming, about the parameter variable naming of our classes. Okay, remember that the method is the only thing that we should be able to see, right? So what you name your variable is really not important. In fact, you know what? I think it would be a good idea. Where is it? Just a brief moment and show an example. Of what I'm talking about here. All right. Today. Let's say we have a variable called, an integer variable called, so I might not be able to see it so well, so let me pull it. Okay. We're gonna have a constructor with no arguments that sets my int to 0. We're gonna have a constructor. Oh, that needs to be a capital. Constructor that takes a single variable. And then we're going to have get and set methods, right? And set, void set method. Okay. Is that everybody? Yeah. Okay. We'll create a method for testing this. Okay. Let's see. There's one error. There we go. Okay. All right. So now I'm going to create one with no thing, right? No, no arguments, and then another one with the value 42. That's an important value for those who are in the know. All right, MC2, and then we're going to change the value So we're going to change the value of the first one based upon the value of the second one and add 4 to it for some reason. Just a random value that I came up with. Okay, so now let's see if we can compile this. Okay. Oh, forgot to give it a variable type. Did anybody comment on that? Okay. Let's try that. Okay, so now when we go to run it, we should see. All right, the first value that should display is, I guess maybe how about this? Say 1, 2, 3, 4. Just write down the four values that should display here. Oh, I did something wrong. All right, pause for a second. Let me make one change. Forgot this should be 1, 2, 1, 2. Okay. Okay. So now, just write down write in the comments the 4 values it should display. MC1, MC2, MC1, MC2. All right, so let's see. Some of you are giving answers. We'll let you, a couple more of you give. Okay, let's see. So 0 is the first one. And then most of you got that one, good. 42 is the next one, good. Okay. Nothing should display here, right? Right, good, yeah, because this isn't a display thing. So now MC1's value is MC2's old value plus 4. MC2's old value is 46, good. And then finally, MC2, it never got changed. It should still be 42. Okay. Now, here's where the question is that some of you are asking. You said, in the example, well, Hojam, you said that variable name should start with a lowercase letter, but in the assignment description, you started that with an uppercase letter. I don't know which one I should do. Right? Some of you have asked me that question, and it's a good question, right? Because it's confusing maybe a little bit. But what I told you guys was, you know what? This is a private variable. We shouldn't be able to see it anyway. We should not be able to see this variable. The only thing we should be able to see is this, right? And this, right? And this, and this, right? So we could change this variable to anything I want it to be. All right. I could change it to that. As long as I keep it the same throughout. All right. And I actually don't even have to change this one. I don't change this one. All right. I can change it here. I don't even have to change it here, right? And notice that as we compile it, making sure I changed it everywhere, good. When I run it, same output, right? because what this is called doesn't matter. We can't see it. It's private. Nobody can see it. I can call it anything I want, right? I suggest you pick a shorter variable name than that, right? The important thing that we can see is this method here and this method here. And again, even this variable name doesn't matter. The only thing that matters here is the type. I'm passing it an integer type. That's the only thing that matters. Same thing with here. What I name it for my local method, anything. You can name it anything you want. You could call it, you literally could call it anything. Okay. Compile and it should run. And we should see the same output as we did before. Okay. All right. But that was, like I said, that was a good question. But the main thing is, this is the only thing I should be able to see, right? I should only be able to see this method and this method, right? Now, in my opinion, it makes sense to call your local variable the same thing that this method is called, right? You know, with the lowercase, as we said. But in practice, the compiler doesn't care, right? And as far as executing, doesn't care. Okay. All right. So back to throwing exceptions. Somebody gives us a radius. They give us a radius that's negative. Now, should we display something? Well, what if sometimes we want to display a message to the user saying, hey, that radius value is an invalid value? What if sometimes we want the program to end? We just want to end it. Let me give you an example. There are certain things that should end a program. So if I go to the ATM, the bank machine, and I put my card in and I enter an invalid PIN, right, invalid code, 4-digit code, it should end the program, right? It shouldn't allow me to go in and enter a valid, take money out or anything like that, right? But now, if I put my card in, put the right code in, and let's say the total that I have money in my account is 300 lira, all right? And the program says you can take out a maximum of 3,000 lira per day. And I say, well, that sounds nice. I want to take out 3,000 daily. So I enter 3,000. It can't give me 3,000. It shouldn't give me 3,000, right? But do I want to end the program because the value entered is greater than the amount in the bank? Probably not. My customer probably doesn't want to have to go back over and start from the beginning just because they entered a wrong value, right? So if I enter 3,000, which is more than the 300 that I have remaining, it should say, you know, that's an invalid value. We're going to go back, not to the beginning of the program. We're just going to go back to the part where you tell me how much you want to take out. All right. And that would be how this throwing exceptions could work, is by throwing the exception, we give the calling program, in this case, the Pata Checkmate, the take the money out program, we give that program the chance to handle the exception itself before it decides to just end the program completely. Okay, so in a sense, so the way I like to try to explain this is, oh, I don't have my American football with me. Darn. Okay, so if we were in a classroom setting, I would have brought my football, American football, with me to show you guys. So in America, we have a game that we call football, but doesn't use our feet, which is really kind of weird if you think about it. Football in the rest of the world makes a lot more sense. You use your feet to kick the ball. Okay. But when I take a ball and I throw it, right, to my receiver, to someone who's trying to catch the ball, right? So now, if they catch the ball, right, no one else has the ball, right? If they catch it, they hold it, they run with it, right? No one else gets the ball. Now, they don't have to catch the ball. If they don't catch the ball, someone else might be able to. Right? And so that is what we're going to get to, right, here in a moment about catching exceptions. So here, by throwing an illegal argument exception, by throwing an exception instead of displaying something to the screen or doing something else, I don't know what else you would do, right? Not only does it not require me to return a value from this calling program, from this method, right? So this is a void method, so it doesn't return a value anyway, but what we'll see in a moment is that we won't have to return a value, right? And in addition, we can let the calling program decide what to do with the exception that was encountered. Does it want to display something to the screen? Maybe. Does it want to end the program? Maybe. Does it want to write to an error log, write to a file, an error log? Maybe. These are all things that we can let the calling program decide what to do. We don't have to decide that in our method. The only thing our method does in this situation is it ends itself, it ends the method, and it tells the calling program an error occurred and you need to do something about it. Either catch it or let it go. Okay. And if you let it go, the calling program, your calling program will have to catch it. And if that lets it go, it keeps going up and up and up until it either does get caught or it ends the program. Okay. Where are we? Okay. So let's talk about catching exceptions. All right. Now, we can catch the different types of exceptions based upon type, or we can catch the parent class exception. Let me see, where was that? Is it here? Oh, this will work. All right. So we can catch any type of exception, right? Arithmetic exception, file not found exception, index out of bounds exception. We can catch a parent type, runtime exception. We can catch the exception where any exception that occurs. Now, there will be some rules about this, and we'll talk about that. All right. There will be some rules about how we can do that here. Okay. And I'll show you some of those in the maybe if we have time in the second hour, we'll get to that. Okay. But we can catch any exception type. So let's say an exception is thrown in method 3. Right? So exception here is thrown in method 3. Okay, so we try. Right, so the try block means that this is a block of code in which an exception could occur that I might want to catch. Okay. An exception could occur in here, and I might want to catch it. So let's talk about the different types of exceptions that it could be, by the way, but we'll get to that in just a second. All right. If you put code not in a try block, if an exception occurs in that code, It can't be caught inside of the method that you're in. It will have to be thrown up to the calling program, to the method above. Okay. So let's talk through this example based on the 3 different types of exceptions. Sorry, there's 4. Let's count 4 different types of exceptions that could occur and what will happen. Okay. First possibility, the exception that's thrown in method 3 is of exception type 3. Okay. Okay. So it's type 3. All right. Statement 5 will not happen. Statement 5 will not happen. It'll jump straight to the catch block. It is of the type 3. It will process. Sorry, need to erase that because I didn't mean to draw through that. Okay. It'll process the exception 3, and then it will continue on. It'll execute statement 6. It'll return back to here. It'll execute statement 3. It'll execute statement 4. It'll execute statement 1. It'll execute statement 2. All right. It caught here. So if the exception is of type, let me do it this way. If the exception is of type 3, then statements 6, 3, 4, 1, and 2 will all be executed. Okay. So what if the exception is of type 2? Okay. All right, so an exception occurs here. It's of type 2. It skips over statement 5. It jumps to the catch block. The catch block says catch exception type 3, but this isn't of type 3. It's type 2. It's this exception 2 type. So it won't do this. And it won't do statement 6 either. Because the exception was not caught by this method, method 2, it'll throw it back up to here. So then statement 3 won't execute. It'll jump down to exception 2. All right. I guess here I should say the process statement will execute. All right. So then it will process exception 2. Then it will continue execution from there. Statement 4, statement 1, statement 2. Okay. Fine. Second to last. You'll see why I say second to last in just a moment. Question? No. Okay. Exception is of type 1. Exception is encountered here. It skips over statement 5. The catch block. Oh, it's the wrong exception type. I can't catch exception 1 using exception 3. So I don't process it. I skip over statement 6. I didn't catch this exception. Somebody else needs to catch it. It's going to come up to here. So an exception occurred here. So skip over statement 3. Try to catch it. Oh, it's the wrong type again. I don't process it. I don't execute statement 4. I throw it back up to here. I skip over statement 1. Exception. Oh, this is the right exception type. I process it. I execute statement 2. Okay. There is a final possibility. We'll call it exception type 0. Meaning that it is none of these. It's not exception type 3, it's not exception type 2, it's not exception type 1. It's something else. It's not any of these. Okay. It's encountered here. We skip statement 5 because we can't continue executing if an exception occurred. It's not caught here. So therefore we don't continue this method. We jump back up to here. We skip statement 3, wrong exception type. It wasn't caught in this method, method 1, so we throw it back up to here. Exception occurred here. It's the wrong exception type. It's not called here, so we throw back up to here. But if that's the main method, what happens? What happens? All right, the program ends. The program ends, and you get a method. You get an exception trace that gets displayed to the screen. Okay, so let me show you what this might look like here in this code. Okay, let's do this. Let's create a method here. I'm gonna do. Let's call it my method 1, my method 2, method 3, my method 4. Okay. And then just realized. My method 2, 3. Oh. And what we'll do is we'll do a try block here. So let's do. I'm gonna have to import that, huh? Let's do this through. Let's first catch the one that's actually thrown. Let's. Oh, I guess I need to actually call the first method, don't I? Okay. This should work. I don't see any problems, but that doesn't mean there aren't any, right? Oh, static. Static keyword. Constantly. Oh. Oh. Oh yeah, it's okay. I'm gonna take this out just because. Actually, you know what? There. Now I remember what I want to do with this. If my int is less than 0. should be good. Let's see. Let's make this a -5. Now this should be fine. Okay. Now, oh, I meant to. We're going to walk through and see how this works out. Okay, so we step in, we do this. We're going to call this method, right? We're going to call down here. Now we're going to call into here. Right, now we're going to call into here. Okay. Is my int less than 0? The answer is no, so there's not going to be any exception being thrown. So now I'm going to display in my method 4, right, after the exception in method 3, right, in method 2, method 1. Now I'm going to call it with the -5. Keep drilling down just like I did before, but now it is less than 0, right? So now I'm going to throw that exception, which means I'm not going to execute this line. Right? So that line didn't get executed. It did before, but it doesn't now because the exception occurred. If an error occurs, it skips all remaining lines of code until it gets caught. So now I'm going to display the exception was caught. I'm still going to display after exception because the exception was caught and processed, which means now there's no more error to deal with. Okay, so then we back out doing the same thing as we did before. Okay. So now, what if this is the wrong exception type? What if this is the wrong exception type? It doesn't like me. Okay, I'm past due for the break time, and what I'm trying to do is going to end up making me put it here too. And I guess I can do that because I want to show you what's going to end up happening if the exception never gets caught. Okay. So here, same thing as before, right? With 5, it works fine. Okay, but for -5, it's going to keep calling. Now it's going to throw the exception, but not get caught. It didn't get caught here, so it threw it back up to here. It didn't get caught here. It threw it back up to here. It didn't get caught here. Threw it back up to here. It didn't get caught here. Threw it back up to here. Back to here. This is what happens if the exception never gets caught. We end up with an error in the main program. This probably looks familiar to you, doesn't it? You've probably seen something like this many times before, where you had an error in your program, right? Now notice it tells us the call stack, right? So this is where the exception actually occurred. This is where the method was called that caused this exception. This is where the method was called that caused that exception. This is where the method was called that caused that. And this is where this one. So where was the error really? What happened with the error? Well, was it because we called it with a negative number? Maybe. Is there something down here that's a problem? Maybe, right? It could be either of those. Right? But when you get something like this, it means that there was an exception that was encountered that never got caught through its call stack. But we can trace down to where the actual exception is. Okay, so that we can determine what happened, what really happened to make this thing occur. All right. Are there any questions before we break? I'm a little bit late on the break, so we will take a 10-minute break time until 4:35. Does anyone have any questions before we take a breather? Okay, all right, let's break and we will come back at 4:35.